Okay, so good afternoon, everyone. Welcome to this week's Google Hangout for data analysis using Sigma plot. So today I'm going to go over the material that we have in week 4, which is principally related to analysis of data using one-way analysis of variance, or the Kruskal-Wallis test. So what I'll do now is I'll flip across to the Keats webpage, and we'll go from there. Okay, so here's the landing page at Keats. And as you hopefully know already, if you are enrolled, then you can click on data analysis for biomedicine using SigmaPlot, and this will take you into the module. And you'll see here the landing page. And this week's data, if we this week's material is down here at week 4. So if you click the one-way ANOVA or Kruskal-Wallis tests, then you'll find out more about these. So this is the week 4 page. And again, the material can be accessed down here from these tabs. And as in all the other weeks, there's 2 sets of material each week. So in the first half of this week's material, you'll learn about one-way analysis of variance. And then in the second half, you'll learn about a very similar test, which is called the Kruskal-Wallis test. And if you've been participating so far, you should have learned that there are 2 types of tests, broadly speaking, 2 categories of tests, the parametric tests and the non-parametric tests. And the one-way analysis of variance is a parametric test, and the Kruskal-Wallis test is a non-parametric equivalent test of the one-way analysis of variance. So they basically both do the same. They do the same thing, and they're useful for analyzing the same types of experiments. And SigmaPlot will tell you, based on your data, which one is the most appropriate to use. So if we click here on the experimental design page, the first experiment you'll encounter in this week's material relates to the density of brain cells in 3 different species of animal: aardvarks, badgers, and cats. And let's suppose that you've measured the mean brain density in 4 aardvarks, 5 badgers, and 5 cats, and you wish to know whether the mean density of brain cells differs between species. So for example, perhaps you think cats have more dense brain cells than aardvarks and badgers. Okay, so then if you click on this tab here, you pop up a little Vimeo or YouTube style video, and it will tell you about the experimental design. So I won't play the whole thing, but you would access that by clicking on this tab here.
So the first rule of data analysis is to have a look at our data. So open up example 5 and double click on example 5 data and make sure this tab is uppermost. Now click on the analysis tab and histogram. And you should be very familiar now with inputting the data. So here are your Y values, the density of the cells in the brains of these 3 different species. And then it's going to put some output in the first empty columns that are available. Click Finish. And now, looking at this, it's fairly obvious that this data appears to be normally distributed. It's got a pretty nice peak in the middle, maybe slightly shifted on that side, but we don't have that many samples, because this is just the result of a single extra count in this column.
And so the remainder of this video will talk about the normal distribution. But what you should have learned by now is that if your data is relatively normally distributed, then a parametric test might be suitable. So then in the next video, if you click here, you'll learn how to analyze this data using the one-way ANOVA. So let's play this video.
Okay, so the advisor wizard should have told you to use either a one-way analysis of variance or the one-way analysis of variance on ranks, which is also called the Kruskal-Wallis test. So to run these analyses, let's make sure that the data is uppermost. Click on the Analysis tab and then select One-Way Analysis of Variance and run. Again, it will say you have to put your data in either the rule or index form. We use the index form as here, then you click Next. And our factor, which are the species, with 3 different levels, A, B, and C, is in this column, and then the data, which are the Y values, these are the density of the brain cells per animal, it's in this column. Now click Finish. Now you didn't get any warning messages, so it's happy to run the one-way analysis of variance for you. So in this case, it didn't recommend that you run the one-way analysis of variance from ranks, the Kruskal-Wallis test, because your data did appear to be normally distributed, and the error bars appear to be of similar sizes between the groups. So under these two conditions, one can run a one-way ANOVA. So the stats package tells you that there is a significant difference between the levels of this factor.
And so you can listen to the rest of that video to learn a little bit more about the one-way ANOVA, and then how to determine which groups differ from which groups. And this is a type of test that you run after the one-way ANOVA, which is called a post hoc test. And in this case, SigmaPlot is recommending the Holmes-Sidak test. But you can learn about a variety of these different tests in this short video. If you click on this tab, you'll also learn a little bit more about these post hoc tests. And if you scroll down, you can read this at your own leisure. So that's the first half of the module. This relates to the one-way analysis of variance, which, as you'll learn, is suitable for analyzing an experiment where you've got one factor, for example, species, with more than two levels. In this case, we've got three levels: species A, species B, and species C. So the one-way ANOVA is suitable for where your error bars are similar and you have your data is drawn from a population with a normal distribution. Now, quite often in biology, your data isn't quite as beautiful. So your error bars might be much larger in one group than another group, or your data may not have a really nice normal distribution. It might be very skewed, for example, or you might have lots of numbers near zero. And under those circumstances, you might be better advised to use the Kroskal-Wallis test. So if we click here, there's a video which shows you another data set where the data is skewed. So let's look at this data now.
So in this next video, following the first rule of data analysis, I'm going to inspect our data. So we make sure that we've opened example 4 data and double click here so that this is uppermost. And then we'll click analysis and histogram. And you should remember from before that what you do is for the source data for your histogram, you click here, which is the size of the fish, and then it will ask you where to put the output. And we're going to let it put it in the first empty column, which is here. So it will fill these rows with data. And if you click finish, accepting the default settings, you can see a histogram. And you should ask yourself whether you think this data is normally distributed or not.
So if we pause the video there, what we're seeing in this different data set is that it doesn't have a nice bell-shaped curve. In fact, lots of the values in this data set are near zero. And so this is an example of skewed data. And this probably isn't suitable for analysis using a one-way analysis of variance unless you do something else with it. And so in this case, SigmaPlot would recommend that you might use a non-parametric test called the Kroskal-Wallis test. Now, another useful thing you can do is if you plot your histograms and the data is not normally distributed, it's also wise just to plot a bar chart with error bars to see if the error bars are similar or different to one another. So let's click on tab 10 and learn about that now.
Now that we have inspected whether or not the data appears to have a normal distribution, we can plot a bar and error bar graph. So if you click here and then right-click and select New Graph Page, we say yes, we'd like to create a new graph. And here it says, what kind of graph would you like to create? And we're going to select a vertical bar chart like this with error bars. So we click Next. And we'd like simple error bars. Here, we'd like to see category, mean, and the standard deviation above and below the mean. And click Next. And asks us to have our data arranged in category, Y, which is what we got here, category, Y, which is the size of the fish. So we click Next. So the categories are found in this column. That's the depth, 1, 5, or 10 meters. And then the Y values are the things that we measured. Click Finish. And now what you can see here is a graph showing the average size of the fish, 1 meter, 5 meters, and 10 meters, with a standard deviation above and below the mean.
And so if we just stop the video there, you've now learned how to plot the histogram for this data and a bar chart for these three groups. So now let's try and run the one-way ANOVA. Now, you might think that's not a great move because we know the data is not normally distributed, But let's see what SigmaPlot does when we ask it to run the one-way analysis of variance. So let's play the video in page 11.
Now, let's try and analyze the data to see if there is a significant difference between the groups. When you consulted the advisor wizard, you should have found two tests that might be appropriate for this data: the one-way analysis of variance or the Kruskal-Wallis test. Let's see what happens if we try to run the one-way analysis on variance. So make sure your dataset is uppermost and click on the Analysis tab. Then we'll select one-way ANOVA from the list. Make sure you don't accidentally select ANOVA on ranks, one-way ANCOVA, or one-way repeated measures ANOVA. The one you want is nearest to the top, one-way ANOVA. Now click Run. And a window pops up and it says, do you have your data in a raw or indexed format? And we'll use our indexed format data that is here as usual. The group is the factor, which in this case is 3 levels, 1 meter, 5 meters, and 10 meters. And the data, which are the Y values, are the size of the fish at those depths. Click Finish, and SigmaPlot gives us a warning.
So this is not something you should worry about. SigmaPlot gives these warning messages to help you, and we just recommend that you follow SigmaPlot's advice at this level of your education. So what it's telling you here is the normality test has failed, and that's because when we plotted the histogram earlier, there were lots of values near 0. SigmaPlot is now saying, would you like to run a one-way ANOVA on ranks instead? And this is the Kruskal-Wallis test. So this is an alternative test that's suitable for data which is skewed, or if you had a group where the error bars were much bigger than the other groups. And when you do that, it will then switch to the one-way analysis of variance on ranks, and it will give you the results in the following window. And if you want to learn how to interpret the data or the analysis, then continue watching this video, and it will explain where you get your p-values and what those mean. And then finally, in this week's material, you can also plot this kind of data using a box plot. So when you analyze data using a non-parametric test, like a one-way analysis of variance on ranks, the Kruskal-Wallis test, some people recommend that you plot the data using a box plot rather than a bar chart. And if you were to click go on this video, you'll learn how to plot the box plot instead of the bar chart. So these are the two sets of content for this week. You've got the one-way analysis of variance and the one-way analysis of variance on ranks, or the Kruskal-Wallis test. So if you have any questions when you're working through this, feel free to drop me an email or post a message on the forums, and you'll find the links to the forums at the bottom of each page. So I hope you find this material useful, and good luck on your continued studies. Next week, we'll learn how to do factorial analysis of variance. So that might be, for example, a two-way analysis of variance or a two-way repeated measures analysis of variance. So as you see, the material gets a little more complex each week, but it's still not scary. SigmaPlot is going to help you make all the right decisions that you need. So good luck, and speak to you next week.